So yeah, my goal today is I'm gonna show some slides. I'm gonna go through them relatively quickly because this community is pretty well versed already in Kubernetes. I have designed this for the COBOL community understanding Kubernetes to get to it. So I'm gonna get to the code as quickly as possible. But I do have a whole story arc to this, so please bear with me. So let me go ahead and share my screen here. And if anything embarrassing pops up while I'm presenting, I apologize ahead of time. So first of all, if you didn't know, today is actually coffee, the National Coffee Day, which is pretty cool. I love my coffee, but I realize that I really do drink, and you will be seeing me drink these rock stars, and I've purchased it 10 times. So yeah, subscribe and say it's dangerous. Just gonna say that. Anyway, thought that was funny. Okay, so let's just talk about this. Like I said, I'm gonna go through these slides really quickly, just kind of to kind of get the lay of the land. And again, hi, I'm JJ. I'm a developer advocate for the IBM Cloud. Yes, I do have the email address of awesome@ibm.com. And please, if you ever want to talk to me, find me on Twitter @JJAsgar. Okay, as I said, the agenda, we're just gonna have a nice general overview to make sure that we all understand the same things. Talk about cloud native development and terminology, which we already probably are pretty well versed in. And then why this is important to understand. And then the goal of the talk, which is probably why everyone's here, is to show a basic example of an ETL pipeline based on COBOL on Kubernetes. I want to make sure that this is very clear that this is not production code. This was a science experiment that I came together and kind of figured out, which was really, really fun. The COBOL ecosystem is massive, and I will talk about that a little bit later, but this is just, again, something just so bonkers that is just fun to find out, especially if you're coming from the cloud native ecosystem. Okay, so again, I'm gonna go through these very quickly. If you do have questions, I do have the chat open. There is a little bit of delay, but please don't hesitate to put a question in the chat if I do bring up something and you would like me to follow up a little bit more. First thing first. Everything inside of Kubernetes is based off of something called a container. Most of us probably know this. I was recently told that IBM is no longer allowed to use the Docker logo due to branding rules. So there you go. But I can use Podman because of Red Hat, which is awesome. Everything inside of a container has basically the concept, has to adhere to the spec of the OCI, which is the Open Container Standard. I forget what it stands for. Everything uses a container registry where to store the container, and everything is built off of a Docker file. So containers are the entity that is what runs, and that's kind of where the core of this whole conversation comes from. From there, as you start building out your applications, you need some way to orchestrate your containers, and that's where Kubernetes comes into play. Kubernetes is just a container orchestration platform. It is very, very, if you actually really start looking into it very deeply, you start realizing it is very bare bones. There's not a lot of, what's a good word for it? Bells and whistles. There's not a lot of bells and whistles on it. It's just designed to do what it's designed to do, which is orchestrate containers. The more you learn about it, the shocking it gets, and that's why you see the landscape.cncf.io so large, is because the ecosystem has exploded with people trying to fill in things that people need when using Kubernetes. It's also community supported. There are platforms like IKS, for instance, IBM Cloud Kubernetes Service, just saying, that you can have a supported Kubernetes cluster from it, but the main support is based out of communities. It is and again, I want to reiterate that it is a core framework. Next, and also there's no long-term support. So if you're an enterprise, excuse me, you're an enterprise that usually IBM are stuck to, that's usually a pretty big sticking point. More importantly, there's something called out there called OpenShift, which if you didn't know is actually just Kubernetes. OpenShift has had many iterations over the years, but now it is pure Kubernetes with what's a good way of describing it? Opinionated guardrails on Kubernetes to make your life significantly easier, especially as a developer. It is a true production grade, open source, enterprise level of Kubernetes. It is The more I've learned about OpenShift, the more I truly understand that if you are in if you're in the ecosystem and you're looking for an option for Kubernetes for your company, OpenShift is a very, very valid offering. There's some really beautiful things inside of it that give you the velocity that you're looking for your developers to be successful. I will highlight some of the differences as we move forward, just to make sure you see the difference between Kubernetes and OpenShift, just to kind of see where the advantages are. But there truly are amazing. And all the code that I run on the Kubernetes cluster that I'm going to be running on to show the COBOL stuff runs fine on OpenShift also, which I have another repository for that too. Okay, let's keep going. So we all know inside of Kubernetes, there are things called pods, which I'm hoping that the DevOps community knows this by now. But every single pod has n number of containers, as you see inside of here. And as you see at the very bottom, Kubernetes and OpenShift I'm going to just use it back and forth unless I explicitly say something about OpenShift. This can run either place to run it. It's great. Pods are how everything gets ran in Kubernetes. A deployment is you telling, hey, Kubernetes, make sure that n number of pods are running. In this case, there are 2 deployment replicas right there where pod A1 and A2 exist on 2 different entities inside of this cluster, which is important. One of the ways we use this, we actually create a deployment for COBOL to do this. Failure recovery, something always breaks, something blows up. Because you have a deployment replica of, in this case, in the top 2, they'll always make sure that a second one is running. When pod A2 blows up, it starts it up on somewhere else. Same as with pod B there. If it blows up and the deployment replica is set to 1, it'll make sure that it spins up somewhere else, which is good. More importantly, nodes are actually the CPU that is run that the Kubernetes cluster or OpenShift cluster uses. It is, in essence, just an API to compute when you start looking at Kubernetes. And it doesn't really matter. As long as it runs the kubelet, it can run, be a worker node inside the cluster and run. As a consumer of OpenShift or Kubernetes, you don't know where your machines are run. Granted, you can put affinity and anti-affinity rules on it to make sure that the pods run in specific places. For instance, if you're doing ML and you need a GPU or something for a specific node. But in general, when you are consuming Kubernetes, you don't know where it runs. The orchestrator deals with it for you. Okay, so let's talk about some internal concepts just to make sure that when we get to the actual COBOL application, we all are speaking the same language. Service discovery, because we all need DNS, more DNS in our lives. There's something called kubedns inside of Kubernetes, which allows you to declare internal communications so things can find one another, which is very, very important. A node port, that is how you declare a service to talk directly to a specific port inside of a container. In general, my strong opinion is that you shouldn't use these. There are people who disagree with me, but I'm on stage, so I get to say don't use these. We can have that conversation at a later date if you so decide to have a different conversation with me. In this ecosystem of using Kubernetes and OpenShift, a term that you need to really kind of grasp very early on, which has really, really, really made things strong to be able to, effective is a good word for it, is something called namespaces. Namespaces is how you can logically cut up your Kubernetes or OpenShift cluster to be able to make sure that you have exactly the same setup that you would have for dev, QA, or prod, for instance. So you could actually use the exact same hardware, so you don't have that QA environment that is like a fourth of an old machine sitting underneath your desk in your office or whatever. It's actually the same hardware you're running, and it is all walled gardened off by using namespaces. That is the general statement. I will say that people have really, for lack of a better term, abused what namespaces do now. And there are some people who've found ways to break out and take advantages of different things inside of it. But in this conversation, it's a walled garden. You can't leave it. Don't get me wrong, there's some really cool stuff you can do with it, but for this conversation, it's a walled garden. On top of that, it turns out OpenShift has actually turned the accelerator on to namespaces, where they created something called projects. Now, I actually got this advice from some of the dev advocates over on the Red Hat side for OpenShift, where when you start developing on OpenShift specifically, because projects are so, for lack of a better term, ephemeral, where you can think of them kind of like Git branches, where you are ideally using feature branches with your development, where you take main or master down, you do your code, you make a new branch, you make your code, and you merge it back in. Well, you can do that almost exactly the same thing with projects, where you can just create project 1, project 2, project 3, until you get to the point where you want it to be. And then you take that same project, all of the YAML and all the configuration inside of it, and then turn it into, for instance, payment prod here. Most importantly, if I was a random anonymous person here in the center, this is trying to imply that I would only have access to production or payment dev here. But if I took that same code and gave someone to payment prod, after iterating so many times on the projects to do it, they could actually deploy exactly what I got up and running inside of payment prod, which is great. And obviously, I don't want to have access to the catalog or inventory, because if I'm just dealing with payments, you shouldn't, separation of powers, right? On top of that, when you start looking into the different services inside of Kubernetes, load balancers are usually what you end up seeing, is because you have n number of pods there. With n number of pods means you need some way to load balance in front of it. There are multiple different load balancers inside of there. You can even pull out the default load balancer and put in your own if you so choose. There's so many knobs and dials on that. You can actually have a whole talk just dedicated to load balancing inside of Kubernetes, just to make sure that we all have the same conversation. Load balancer allows you to basically talk to n number of pods in front of the service. If you want to go into deeper, find me afterwards. I'm actually still learning this stuff, and I would love to hear what you know about these things. Ingress is the hardest conversation to have inside of Kubernetes. Because we're not actually going to be doing anything with Ingress with this presentation, I'm going to go ahead and just skip along and move forward. But Ingress is important to know, especially if you're trying to learn Kubernetes, because it is how everything kind of maps together on your application stack. But when I did talk about how important Ingress is, I do want to highlight something called routes that are come from OpenShift, where a route is actually an automated way to create an ingress rule with like 2 commands. So if you've ever played with ingresses before and you're like, JJ, this is a fucking nightmare, it turns out OpenShift gives you a really, really, really nice interface to create very easily exposed applications on OpenShift, and does the lion's share of the work for you, which is always wonderful. Okay. Let's talk about some ecosystem, just to make sure if you've never seen this before, you at least know what these things are. It's always important to know, because they do come up in conversations, especially if you're just walking into this world. First of all, Helm. Helm has become the de facto package manager. Be sure to know about it. It's important. Cool. Let's keep going. Istio is something called a service mesh. It is the way that you can do intelligent routing and ways to the next level of networking, if you will, inside of a Kubernetes cluster. There's a lot more there, but again, this is not talking about Istio. I just want to make sure you knew what this is. Service meshes are usually a intermediate in conversation you should have when you're talking about Kubernetes. When you're first coming into this world, especially if you're coming in from the COBOL side or the legacy application side, or however you want to describe it, the non-cloud native side, you should probably understand a little bit more about vanilla Kubernetes before coming here, but do know that Istio does exist. Knative is the service platform on top of Kubernetes. There is some really amazing use cases around Knative and things you can do with it. And that community has exploded since the last time I looked at it. I'll be honest with you, I haven't spent much time there, but serverless does have a place for everybody. There are some really interesting use cases with it, especially if you have tight budgeting restrictions with your hardware. Knative and serverless can really do some interesting, important things. So keep that in the back of your mind. Okay, so now that we've talked about all the cloud native stuff, just so we all have the same conversation and we all know what I'm talking about when I start talking about the different portions of it, let's actually talk about how COBOL fits into all this. So when we usually think of COBOL, we usually think of, you know, this picture or some red or green text with some weird stuff called procedure divisions and a lot of numbers and things. So that's accurate. I mean, that was how COBOL was, but believe it or not, today, COBOL actually runs a huge portion of our world. As it says here, 87% of all credit card transactions and nearly 8 trillion payments per year are all run by COBOL. COBOL is actually a modern standard of development and has some unbelievably amazing modern day technology underneath it. It's just that it's, you know, it's sitting inside the mainframes ecosystem in the Z series, and it's not like it is unbelievably powerful, and it really does run our world. Those moments that you've been probably checking into that flight or when we were allowed to fly, believe it or not, COBOL was probably in there. You spending your credit card to do something, COBOL is probably part of that platform. Also, as we saw at the very beginning of the COVID outbreaks around the United States, New Jersey had a problem with, uh-oh, did I lose it? Am I still on? PJ, you there?
You are still on as far as I can tell.
Okay, cool. All right. So yeah, my little thing broke. Anyway, I'll keep going. So COBOL was really important and integral to the unemployment industry oh, okay, technical difficulties. Okay.
It's like we're having a little bit of a problem.
Yep. Should I keep going or should I just give it a rest?
Give me a second. Let me ping James and see.
Okay. Oh,
okay.
There we go.
Let's hit play. All right, go for it.
Okay, cool. Okay, let's get to the code because that's the whole reason why we're all here, because we want to see it, right? So let's keep going. The goal was to prove that any computer language can run on Kubernetes. I picked COBOL because COBOL, right? Like it's there, it runs the world, and I wanted to show that it could work on Kubernetes. My challenge was very basic. I wanted to run a COBOL application that adds 5 to a list of numbers. That's literally it. As you see here, this is the actual code that I wrote. Well, I got some help to write it, but I wrote a COBOL application, so I'm kind of proud of that. So I can, you know, put that on my resume now. But anyway, it's very, very basic, and I will share the links to all this because this is all on GitHub that you can try yourself too at home. So I'm going to use GNU COBOL. This is actually the container that, or the Docker file for the container that I used to build GNU COBOL, which is the open source COBOL standard framework to be able to do some stuff. As you can see, it's very, very straightforward. Basically, we build the compiler, pull in the COBOL application, then we compile it into the COBOL app, and then we just run it. I also have some scripts that I run, which I'll show here right now, which is basically our basic ETL pipeline. If you don't know what an ETL pipeline is, it means extract, transform, and load. So you basically extract some data, you transform it or munge it or whatever, and then you load it into something else. So this demo here, I have an S3 bucket with a bunch of numbers on it, which I'll show here in a second. I have a little, literally something called watcher in that sits there and constantly pings against it, looking for the file. And then when it files it, puts it over into a volume and then runs a COBOL application against it, which is the one I just showed you. And then it ships it somewhere else. So in essence, it's just a very simple one, but it really does walk through the process of everything going on. So let's actually do it. Okay, first thing first. I do want to just quickly point this out. If you don't know, inside of, with the IBM Cloud, you can get a free Kubernetes cluster for 30 days. And I have learned that very few people know about this and or haven't been able to figure it out. So in my beautiful automation way, I do want to plug real quick saying that you can use this repo that I created 27 days ago to automate building that cluster for you. So anything you learned here today, you can run this, and which I'm going to be doing here in a moment, on one of the free clusters on IBM Cloud, where you can actually play around with this. So if you actually being like, JJ, this doesn't work, or JJ, you're a liar, I challenge you to try it at home. Okay, so here's the actual repository. It's called COBOL on K8s. Basically, it has all the same kind of steps through it all. But what I want to make sure first is that I have my numbers here, which is right here. So as you can see, these are the numbers, just literally called numbers.txt, out on an object storage on IBM Cloud. And of course, you know, always got to be leap, right? Hopefully somebody laughed at that. God, I really, really, really hope somebody at least giggled, but we'll see. Okay, so if I come back over here, and here is my code. PJ, is this big enough?
I'm sitting here nodding like you can see me nod. Yes, that's big enough. I think it's good, but I'll keep an eye out in the comments just to be sure.
Awesome, thank you, sir. So I'm gonna go ahead and just do kubectl get nodes, and as you see, we should have one. Should have one. What is? Come on, computer. What? There we go. So as you see, I have a IKS cluster with just one node. That's all that needs to be done, where it is nice therefore. So I'm going to go into this K8s real quick, and as I'm going to bring up this deployment.yaml. As you see here, basically I'll run everything through this COBOL batch, which I put down on Docker Hub 2. I'm not going to recompile the container and, you know, show everyone a compiler being compiled. I mean, we've all seen code fly through a screen before, so there's no need for me to show that. But if you want to, you can also pull this down yourself to be able to run it. The goal is that you can just run this deployment and we'll actually see the whole process run. But I want to show you that there's nothing up my sleeves. Well, I'm not wearing any sleeves. This is actually all vanilla, and we are going to be putting the COBOL chocolate, if you will, chocolate sauce on top. I don't know. I thought it might work. It didn't really work. Anyway, let's keep going. So as you can see, I created, I create 3 containers, one called the COBOL process, one called the watcher in, and then one called the watcher out, just like I did in that diagram earlier. Just for completion's sake, I will show here the watcher in. Hopefully this makes it nice and big so people can see. It is literally just a while true, constantly pinging against it, and then W gets down the file, which is great. Then our COBOL, which is our second process, as you can see here, it touches the file because I couldn't figure out how to create a file with COBOL, and then runs our actual application, and then gives us some nice output, and then moves it to another location, which is great. And then finally, the theory being of watcher out here, where this would be another process that ships it to some message queue or whatever. This basically takes that file and pushes it again somewhere else. So I have a deployment with 3 containers inside of it, and I'll show the logs as it walks through too. So let's go first over here and do get namespaces. As you can see, I have JX namespace, and that's it. So let's go ahead and do a K create NS COBOL, just to prove to everyone that it is not there. So there was just created, which is wonderful. And what I can do now is do K apply -f deployment and COBOL. So what I'm gonna do is take this exact same deployment, which you have access to too, and I'm gonna just dump it into our new namespace and do K get pods -n COBOL. And as you can see, we're already running mainly because I've already done this on this cluster just to make sure everything works. And then what I'm going to do is do k get logs for our process here. And what it should say, oops, oh, I can never get that right. It's k get log, isn't it? Oh, okay. There we go. So k logs here. As you see, we have our 3 processes. So what I'm going to do is I'm going to do, I believe it's -c. So we'll look at our watcher in here. Ah, is it -c? Yes. As you see, there we go, -c. We wgetted it in, it pulled in the numbers from our URL. And then I'm going to do COBOL process. And as you can see, it was waiting for it. It saw it. It added 5 to those numbers. 1337 plus 5 is 42. I think there's a joke there, hopefully, which is great. And then from there, I do watcher out. And as you can see, we dumped out the numbers to another location. So that's really it. Like it proves that Kubernetes can truly containerize any language as long as you turn it into a container and just run your application. You just have to wire everything together and it works, which is pretty cool, right? Hopefully, yes. Big question marks above my head. Don't turn your question to me. Wow joke, nothing. Maybe. Tell me you smiled at that, PJ. Tell me you smiled.
Laughing, JJ. I'm all in. I'm all
in. Awesome. Thank you, sir. So yeah, just so here's some links. As you can see, I have the COBOL and OpenShift, COBOL and Kubernetes. If you've never played with COBOL before, we have some great learning paths and training around COBOL on the IBM side. Also, if you didn't know, OpenShift runs on Linux Z. So if you have friends in that mainframe ecosystem, and I may have tickled some level of fancy with OpenShift, you can start having that conversation of getting actual OpenShift running on Z, which is, you gotta admit, pretty damn cool. Here's some modern COBOL development environments. There is some plugins for VS Code, and there's some really neat code-ready workspaces and things like that around there. So the COBOL ecosystem is seeing the cloud-native ecosystem and trying to take things that they can use for it. So it's all there too. And that's it. That's all I got. And I think I hit the numbers, or no, I got 5 minutes, don't I? So if anyone has any questions, I'm here to answer.